Family courses in the cement industry. Presents to you. A series of courses will be explained about rotary kiln maintenance. We follow supporting rollers courses. Course 2 about supporting rollers adjustments. Course content includes 1. Types of kiln supports. 2. Roller adjustments. 3. Roller inclination. 4. Roller and tire defects. 5. Roller and tire reconditioning. Adjustment of rotary kiln supporting roller. The adjustment of the rotary kiln support roller refers to the reasonable adjustment and control of the rotary kiln in order to ensure the long-term safe and stable operation of the rotary kiln, so as to maintain a good operating state, improve the operation rate, and reduce the running cost. Roller adjustments. Why is alignment important? It is the starting point for any mechanical maintenance program for a rotary kiln. Without understanding alignment and the associated mechanical conditions of the kiln, it is impossible to plan maintenance work effectively. The life of refractory is directly related to alignment of the kiln. The kiln must be aligned, so that flexing and distortion of the kiln shell are minimized, and so that loads to the support bearings are properly shared. Flexing and distortion of the kiln shell vastly increases mechanical wear, and can severely reduce refractory brick life. Poor load sharing amongst the support rollers leads to roller and bearing problems. Alignment means positioning the support rollers so that the flexing of the kiln shell is minimized. The starting point is to know how the rollers are holding the kiln with respect to a straight line. Axial forces on a kiln. In the figure, the axial forces on a kiln are shown as follows. 1. Kiln's downhill force. A force caused by the weight of the rotary kiln in the direction of the outlet. The rotary kiln's natural slope, approximately 2 to 4%, causes this axial forces. 2. Friction force. Resulting from friction between the tire and the supporting roller. 3. Thrust roller force. The thrust roller is responsible for this. Summing up these forces is that a kiln on a slope will tend to move downhill as it turns. That downward movement is resisted by both the friction force between rollers and tires and by the force on the thrust roller. This video shows the forces acting on the rotary kiln. 1. During uphill. The forces acting are the friction between the tire and the supporting roller, and force generated by from the thrust roller. 2. During downhill. The forces acting are the weight of the rotary kiln, the slope helps kiln to downhill. Roller friction force. Friction force is shown in this figure. The support roller's direction is adjusted to achieve this result. There are 3 cases. 1. The support rollers, direction neutral. 2. The support rollers, direction downhill. 3. The support rollers, direction uphill. Roller friction force can be summarized as follows. When a kiln roller is not exactly parallel to the kiln axis, it imparts an axial thrust force to the kiln. The direction of this force, uphill or downhill, depends on how the roller is skewed, and on the direction of kiln rotation. In this figure, shows how roller adjustment, counterclockwise kiln. To reduce the load on the thrust roller, all rollers should be skewed to push the kiln uphill, never downhill. Shown above are the correct adjustments for a kiln that turns counterclockwise, looking from the burner floor. In this figure shows how a roller adjustment, clockwise kiln. These are the correct adjustments for a clockwise turning kiln. In this figure shows how a roller adjustment for neutral thrust. Rollers on the discharge pier are often adjusted for neutral thrust. This avoids excessive roller wear caused by dust from the kiln seal. Good roller adjustment. 1. All rollers pushing uphill. 2. All rollers pushing equally. 3. Kiln floating between upper and lower thrust rollers. Or correct pressure on hydraulic thrust cylinder. Roller and tire forces. In this figure, we notice the following. When the force on the tire of rotary kiln is uphill, the force on the roller is downhill. The direction of thrust can be determined by observing the contact or gap at the thrust stop inside the bearing. Also see this video. Bearing thrust arrangements. As shown in this figure. Supporting rollers, FLS type RA. Takes thrust load on, thrust collar. As shown in this figure. Supporting rollers, FLS type RB. Takes thrust load on, thrust ring. As shown in this figure. Supporting rollers, Fuller. Takes thrust load on, thrust washer. If the direction of force on kiln. As shown in this figure. Supporting rollers, FLS type RA. This points, gap, and contact. If the direction of force on roller. As shown in this figure. Supporting rollers, FLS type RB. This points, gap, and contact. As shown in this figure. Supporting rollers, Fuller. This points, gap, and contact. Measuring roller thrust. Important. Rollers and tire surfaces must be completely free of oil when skewing adjustments are made. Only graphite block lubrication is permitted. Roller adjustment. As shown in this figure. Important. Rollers should be adjusted to float the kiln between the upper and lower thrust rollers. As shown in this figure. Important. For rotary kilns with hydraulic thrust rollers. Support rollers are adjusted to keep the hydraulic pressure within specification. Hydraulic pressure. As shown in this figure. The force on the thrust roller can be calculated from the hydraulic pressure indicated on the gauge. Calculation of hydraulic pressure when all rollers are neutral. Calculate the weight of the rotating parts of the kiln, shell, tires, gear, refractory, material load. Multiply by the % kiln slope to get the force on the thrust roller. Divide by the total piston area of all thrust rollers. See this example 2, calculation of hydraulic pressure when all rollers are neutral. Roller adjustment. Let's start important steps and notes for roller adjustment. As shown in this figure, rollers are skewed by moving bearings in or out as required. Note: that the adjusting screws, shown are greased and wrapped to prevent corrosion. Jacks for roller adjustment. As shown in this figure. Use pancake jacks, these are available with forces over 100 tons, to aid in pushing bearings in for roller adjustment. In this step, as shown in this figure, moving a bearing out is easier. A small jack may be needed. In this step, as shown in this figure, always measure and record every bearing adjustment. To keep from changing the kill center, make equal and opposite movements on each bearing. Measuring roller thrust. As shown in this figure, measuring precise roller thrust is possible on FLS bearings using this axial measuring device. As shown in this figure, the axial measuring device consists of a hand jack with pressure gauge, a mounting fixture, and an adapter with bearing to enable readings when the roller is turning. As shown in this figure, the jack is pumped up until the roller begins to move uphill, off its thrust stop. At this point, a pressure reading is taken, and the reading is then converted to tons force. We see how to measure roller thrust in this video from the side. Also, note the equipment used, the measurement method, and the roller pressures. As shown in this video, the axial measuring device consists of a hand jack with pressure gauge, a mounting fixture, and an adapter with bearing to enable readings when the roller is turning. Also shown in this video. The jack is pumped up, until the roller begins to move uphill, off its thrust stop. At this point, a pressure reading is taken, and the reading is then converted to tons force. In two cases, it is impossible to measure roller thrust accurately. Case 1. As shown in this figure. If the grooved roller shaft. Case 2. As shown in this figure. If step-worn roller and tire. Caution. It may not be possible to accurately measure roller thrust if tire and roller surfaces are not cylindrical or if roller shafts or bearings are grooved. Determining roller thrust trial and error method. 1. Find the roller's neutral point, parallel to kill axis, by adjusting the roller skew in small increments, until the bearing thrust contact or gap changes, from one bearing to the other. 2. Once the neutral point is determined, make a small adjustment, to push the kill uphill. 3. While making an adjustment of an individual roller, always observe the kill's thrust rollers, to ensure that they are not being overloaded. Thank you for watching, and I hope these courses are helpful to everyone. Subscribing to this channel Cement Industry Courses would be appreciated. Thank you.